Warm welcome to all. Usually I've planned to do my talk in German, but if I look to the audience, I think it's quite better if I do it in English. So I will do my best and hold this talk in English. My name is Florian Mauser. I'm from the company Verdichter. We are a small startup from Austria, and we have developed a simple oil-free compressor for natural refrigerants. First, before we start, I would like to show you a short animation of our product that you all know about what I'm going to talk about. So these are our three design statements. What was our starting point? First of all was we try to reduce the system to make it simpler. We have got a functional aesthetic in design, and of course we would like to present a better solution for our environment. And that brings me to the next point. The next point is we started to think about compressors in a new way. I'm from the field of tribology. I guess you all know the field of tribology. It is the science of friction and wear. And I was a research engineer in a company, and I did a lot of research in the part of scroll compressors. And I was always wondering, and I know their failures, and they have a lot of wear behaviors and friction behaviors inside. And I was always asking myself, isn't there a nice way to do it better, or do it with under system design? And so I did a lot of research, and I found out that most of the existing compressors what are existing on the market, they are very well developed, they're very well known, they are for decades working. And so we tried to figure out and find something new. And then in literature, I found the system of a rotary piston compressor, and you all see it over here. And there you see hopefully it works, it's the right one. It's the rotary piston of our new rotary piston compressor. And we were asking ourselves, why didn't such a nice system go inside the market? Why doesn't it exist there? And so we tried to figure it out, because the main advantages of this compressor is the simple setup. It's also, we have only a few parts which have been connected together, which are easily produced, and all parts, or the main parts of this compressor are made of aluminum. And so we got a deeper research, and we found out that the main problems in the old system was that they have problems in the sealing and in the part to get the compressor tight. And so we are back in the area of tribology, which my expertise is. And so we did a lot of research in the part of tribology. Here you see one of our test tricks, because as a small startup, it is not possible to always build up a new compressor and run the compressor till death. And so we set up some kind of a test trick that's called a tribometer. You see it here. With this tribometer, it's possible to determine or to do some research in the part of the material science, and also get an outlook of the performance of different material combinations inside the compressor system. And so we developed different optimized tribology optimized material combinations, and also we developed some kind of new adaptive sealing system, which allows to run the compressor without any oil inside the compression process. And that means that we can reduce the costs of the lifetime of the compressor dramatically, and it also gives you a very good a very good behavior, and it's also recognized that something what's the market asking for Ölfreier compressor for natural gases. If you take a look here, we see here this test rig. Inside there we have got our pressure chamber. We can put inside there our test species, different materials. Our sealing is mainly made out of some kind of tribology optimized polymers, and of course to the metallic counterpart. So we put inside here our test samples. We can put some force on it. We have got here a load cell to measurement the system reaction, and also we have got the push rod, and we have here some kind of linear movement. And so I would like to show you in the next slide and the next short video how such a test is running, that you get a better feeling out of it. Hopefully it works. Let's try it again. Yeah, as you see. So we run it on our pressurized system, and we taught them on, and we are recording the friction and the real signal of the different materials inside. And that makes, and there we can do screening of different materials and can also do long-term tests, and we also not have to set up always a new compressor design. So we know in our model test how the behavior of the different material bearings will do in a real existing system. So, and that's the biggest advantage what we have. Finally, I would show you that there we see this easy setup of the design. You see there are only a few parts. There's got this polymer sealing. You see here optimized surfaces. And if we go, and there we have different material combination where we can try out. And so we have, as I said before, we have got this polymer sealing down there. The polymer can, a lot of different polymers, technical polymers around, polyamide or, for example, PEEK or polykentones, but they are not homopolymers. They are all blended polymers and tribology optimized polymers. And to the counterpart, as I said before, our compressor is made out of aluminum. It has to be some surface, technical surfaces have to be applied. And we also have there many different possibilities to do. For example, we have here some kind of hard adonation, plasmic chemical oxidation, and also we can do and edit a few other anti-friction glide coatings inside this in our system. And finally, we get out, if we do different tests, long-term tests, short-term tests, screening tests, we get out some nice figures. For example, here you see, well, that's just going a little bit maybe too much in the science, but I just want to show you we have a very deep expertise to identify and do the modification of tribological surfaces, and what's very important in our sealing system, in our compressor. And there you see different curves which show you, for example, here you see, and of course, as I mentioned before, it's everything Ölfreier without lubrication and heated up to 100 degrees, so there are very rough conditions inside this test rig. And there we see we have we measure static friction, gliding friction over different time scales. They are now just short scales because that was just screening and give you some idea. And of course we can do long-term tests, and later on we can estimate how will the behavior and how long will be the working hours of our compressor now in real life. So that's the next point. Yeah, as I said before, and that was the reason that we found out why this system wasn't on the market till now, because it was a sealing problem, and we solved this problem with our technology. So we know very well how our system works. And the next good thing is that we can do adjustment to different refrigerants. We made tests with propane, we made tests with CO2, and we always have got the right material a combination that the compressor works well, and that is a big benefit even for customers. And so we have, well, that's now a nice picture. So we have a very simple process. We have a simple setup of the compressor itself. The parts mainly made of aluminum, and also the parts are easy to process, also to make it in big scale ratio. So we expect very large scale effect later on in future. But in fact, we found out that not only the refrigerant market or the heat pump market is very interesting for us, So we also found out that there are many other possibilities where we can use this compressor. For example, in the old process chemistry, they all said we have to have some kind of compression, Ölfreier compression for different substances. And it's also come, the food industry comes to us and says we would like to have a compressor where we don't have any contamination of anything. And so the next big benefit of our development is that we have a fully parameterized system. So what does it mean? That means we can, did it work? I don't know, did it work? Did you show the eye movement? So we have mathematical systems created with different shapes, so we can easily adjust our compressor to the benefits what is used. So it meant how much a masker is going through the compressor, how much volumetric parameters we have, so we can adjust it quite easily and quite well. And in combination with our results from our test lab, we can guarantee that we have got a nice compressor for the use from the customer, so what is needed. And that's, in fact, and that's we are allowed to say that we have got something what's measurable. We know we have numbers of it, and we think we have a very good design and a very smart solution for oil-free compressors, especially in this case, for this exhibition, for natural refrigerants. So if you would like to have further information or any question, don't hesitate to ask me now. We would like also, it would be nice if you find the way to our exhibition stand. It's in hall number 9, and we have the stand 109. So we welcome you very warm there. There we also have got our prototypes there, and we also have got a real system, the moving eye, and you can take a look there. So thank you very much that you joined my presentation. If you have any question, please, I'm open for questions. Thank you very much.